We've studied the relevant knowledge and principles of the circuit before. We drew the simulation circuit diagram of the sound and light alarm detection module on Multisim. As for the unavailable components in the component library, we chose to replace them with those with similar parameters. Also, we measured the operating parameters of the circuit to verify whether it was able to realize the alarm function. Next, we're going to use software to simulate it. The sound and light alarm detection module designed based on the schematic diagram is to be simulated this time. Verify the functions of the test circuit. Waveform appears on the oscilloscope, with a multimeter reading of 5 volts and over 900 millivolts. Next, we're going to draw the simulation circuit. Step 1. Create a new simulation file and save it. Left-click File in the General menu bar, select Create of Design to create a blank design. To better save the relevant operating data in the design, first establish a folder and name it, then name the design file as Simulation Experiment of Sound and Light Alarm Detection Module and save it to the folder. Step 2. Carry out circuit design operations in the design file. First, find the relevant simulation components according to the circuit schematic diagram. Set the width and height of the working area as 50 and 35. As shown in the video, we use 8 resistors and 1 slide rheostat, namely R1 through R9. Their resistance values are as follows: R1, R4 are 2 kiloohms, R2, R3, R5 are 47 kiloohms, R6 is 10 kiloohms, R7 is 100 kiloohms, the maximum resistance of slide rheostat R8 is 2 kiloohms, and R9 is 1 kiloohm. Invoke switch S1. Next, call relay K1 and 1 diode D1. Along with 2 red LEDs, LED 1 and LED 2. Two PNP transistors Q1 and Q4, and 3 NPN transistors Q2, Q3, Q5 are utilized. Then, incorporate 6 capacitors C1 through C6, with their capacitances being C1 at 0.1 microfarad, C2 at 100 microfarads, C3 at 2.2 microfarads, C4 at 0.47 microfarad, C5 at 0.047 microfarad, and C6 at 4.7 microfarads. As well as a 200 Hz buzzer LS1. 2 DC power sources and 1 ground connection are also used. In the second step, draw the circuit diagram according to the schematic and connect the corresponding simulation components. First, organize the components in their respective orientations. As shown in the video, K1 is connected to VCC and parallelly linked with 5 resistors R1 to R5. Capacitors C1 and C2, as well as the emitter of Q1. The other 2 pins of K1 are connected in parallel with D1, where the emitter of Q4 is connected to the positive terminal of D1, and the negative terminal of D1 is connected to VCC. One end of R9 is connected to the base of Q4, while the other end, as shown in the video, is connected to S1 and R6 respectively. And R6 is connected to VCC. VCC1 and GND are connected to S1 respectively. The collector of Q4 is connected to the emitter of Q5. To facilitate wiring, we add another ground connection. Therefore, the collector of Q4 and the emitters of Q3 and Q5 are grounded. Through LED 1, R1 is connected to the positive terminal of C6 and the collector of Q5, and R2 is connected to the negative terminal of C6. Similarly, through LED 2, R4 is connected to the positive terminal of C3 and the collector of Q3, and R3 is connected to the negative terminal of C3. The bases of Q3 and Q5 are connected to the negative terminals of C6 and C3 respectively. The negative terminal of C4 is connected to the positive terminal of C3, and its positive terminal is connected to R7. The negative terminals of C1 and C2 are connected and then grounded. R5 is connected to R7 and C5. C5 is connected to R8, and as shown in the video, R5 is further connected to the base of Q2. The base of Q1 is connected to the collector of Q2, and the collector of Q1 is connected to R8 and one end of the buzzer. The other end of the buzzer is grounded. Now choose two multimeters, XMM1 and XMM2. Their negative terminals are both grounded. With the positive terminal of XMM1 connected to K1 and the positive terminal of XMM2 connected to the positive terminal of C6. Next, choose an oscilloscope, connecting its positive terminal to the buzzer and its negative terminal to ground. Finally, connect the emitter of Q2 to R8. With this, the circuit connections are complete. In the third step, we proceed with simulation test. Click the simulation button with the mouse, and the software begins the simulation. Open the multimeter and oscilloscope graph pages to see readings of 5 volts and over 900 millivolts, with normal waveforms, indicating that the simulation has achieved the expected results and is successful. Through this lesson, we have preliminarily learned how to simulate and verify the function of the sound and light alarm detection module. You are encouraged to practice independently after class to reinforce your understanding. That's the end of this lesson. Thank you for watching.